Identify the chemical equation representing the physical process. The evaporation, vaporization, of liquid methanol to form methanol gas is represented by the phase equilibrium. CH3OH is in equilibrium with CH3OH. Write the equilibrium constant expression, Kp, for this process. The equilibrium constant in terms of partial pressures, Kp, is calculated using the partial pressures of gaseous products divided by gaseous reactants. Since pure liquids and solids have an activity of 1, they are omitted from the equilibrium expression. Therefore, the expression for this process simplifies to Kp equals PCH3OH, where PCH3OH is the equilibrium partial pressure of methanol vapor. Read the equilibrium vapor pressure from the graph. Initially, the container is completely evacuated, so the initial pressure of methanol gas is 0 atmospheres. As liquid methanol evaporates, the pressure in the vessel rises due to the accumulation of CH3OH molecules in the gas phase. Once dynamic equilibrium is achieved, where the rate of evaporation equals the rate of condensation, the pressure stabilizes and reaches a constant plateau. According to the provided graph, the pressure levels off at exactly 0.196 atmospheres. Calculate Kp. Substitute the equilibrium partial pressure of the gas into the Kp expression. Kp equals PCH3OH equals 0.196. Comparing this value to the multiple choice options, 0.196 is closest to 0.2, which identifies option B as the correct answer. The correct answer is option B, 0.2.